All right, hello Algebra 2. So here we go, beginning the school year off with adding, subtracting, and classifying polynomials. These first sections worth of notes are kind of big, so I pre-filled it, and then I'm going to highlight things as I go through it here. So it's all about adding, subtracting, classifying polynomials. Monomial is a number, so I drew a 7. Could be any number. A variable, wrote an x. Could be any variable. Or the product meaning multiply of a number and one or more variables with whole number exponents. So we have 5x squared y cubed. The 5, the x squared, and the y cubed are all being multiplied together, and they constitute as one thing. If you think of the word monomial, mono means one. After we talk about a monomial, we're going to move into what they call the degree of a monomial, is the sum of the exponents of the variables in the monomial. So in example 2, we're stating the degree. You start off with 8x to the first. You are looking at the exponent here. So when I look at that monomial, I know it's a degree of 1. And then we move on to 13x cubed, y to the first, z to the fourth. If you notice, you have a whole bunch of different kinds of variables in this monomial. So in order to figure out the degree, we would have to look at all of the exponents in this case and add them together. So we have 3 plus 1 plus 4, which is going to give us a degree of 8 for that monomial. Now, when we transition into a polynomial, polynomials are like mathematical trains in the sense that there are a bunch of monomials attached with a plus or a minus sign. So this is polynomial is a monomial, or sum of monomials could be difference too. And what I ended up doing is basically wrote 4m to the fourth plus 3m cubed minus 7m squared plus 6m minus 4. Okay, this is what they call written in standard form, and I'll talk a little bit more about that in a second or two. When you look at the degree of a polynomial, the thing that you have to remember is that it's not the same as a monomial. And that one example, in example 2 with the 13x cubed, y to the first, z to the fourth, we added up all the exponents because you have different kinds of variables. In this case, the variable is the same. All the terms have an m. So basically what you do is you look at the highest exponent, and we would figure out that since it's a 4, this polynomial has a degree of 4. Okay, what makes it in standard form is if you look at the exponents, it goes 4, 3, 2, 1, nothing. Okay, so it decreases from highest to lowest with the exponents. So it's in standard form. They also call that descending order, which I'm going to kind of hit again when we go through this little paragraph here. So it says polynomial could be classified by its degree and number of terms. The degree of a polynomial in one variable is the largest exponent of that variable, which we just talked about in example 3. A term is separated by a subtraction or addition sign. So that's what I made kind of a comparison to like a train, how you have different parts of a train and they're all put together. Well, a polynomial is just a whole bunch of monomials put together with plus and minus signs. A polynomial of one term is a monomial, so mono meaning one, mentioned that earlier. A polynomial of two terms is a binomial, bi meaning two. Polynomial 3 terms, trinomial, tri meaning 3, and then polynomials are written in standard form, which means that the terms are arranged in decreasing order from largest exponent to smallest exponent. I kind of already explained that in example 3. This is also called descending order. I mentioned that as well. When a polynomial is written in standard form, the coefficient of the first term is the leading coefficient. So in example 3, since it's already written in standard form, if somebody were to ask you what the leading coefficient is, we would say 4 is the leading coefficient. And again, the only way that you can tell this is if the polynomial is written in standard form. Okay, now usually the degree is a stumbling point between the difference of a monomial versus polynomial, and then classifying polynomials are a stumbling point. Not that it's hard to understand, but there is definitely, if you don't spend time memorizing these terms in the different situations, it can become confusing and tricky. All right, so example 4, we have classified the polynomials by degree and number of terms. So if we just simply look at number 10, okay, it has no variable. So the degree, since it has no variable, is going to be 0, and that's called a constant. And since there's only one term, it's a monomial. So 10 is a constant monomial. If you look at 11x plus 8, okay, if we look at the variable, the exponent's 1, so the degree is 1, making it linear. And then it has 2 terms, so that's a binomial. So 11x plus 8 is a linear binomial. If we look at 4y squared minus 5y plus 4, okay, we see we have a y squared and a y. The 2 is the largest exponent, so the degree is 2, and that would be called a quadratic. And then we have 1, 2, 3 terms, which would make it a trinomial. When we look at the last example, we have negative 7x cubed plus 20. Well, if we look at the 3, it's a degree 3, making it cubic. And then we have 2 terms, so it's a binomial or a cubic binomial. Another thing they might ask you is they might give you some mathematical expressions and ask if it's a polynomial or not. When you're looking to determine this, I gave 2 common examples of what don't qualify as a polynomial. Like if you have the variable in the denominator, if you have a square root. Okay, another common one, maybe they give you a variable in there that has a fractional power or a negative power. That wouldn't be a polynomial either. But the 2 that I have listed there are kind of the most common. And then to round out the lesson, polynomials could be added or subtracted. Okay. For the first example here, we have find the sum. Sum means addition, so write the answer in standard form. If it's an addition problem, you can just drop the parentheses of the quantities. So I just wrote it as 3x squared minus x plus 2 plus x squared plus 4x minus 9. Okay, and then it's about combining like terms. Now what I would recommend doing is I use the underline method, and I start with the highest exponent. So if you kind of notice, I started off with 3x squared plus x squared, which is going to give us 4x squared. And then negative x is the next highest power, plus 3x. When we combine that, we get a positive 3x, and then we have a 2 minus 9 for our last ones that we need to combine, which would give us a negative 7. If you use the underline method, it kind of organizes the problem, and then if you start from highest and go to lowest, automatically your answer is going to be written in standard form and descending order. Okay, and then the last example here, we're going to look at finding the difference, or it's a subtraction problem. And the thing that you're going to remember with subtraction problems is to distribute in the negative sign. So in the first quantity, you just drop the parentheses. You're going to get a 9r squared plus 6r plus 16. And then you got to distribute in the negative sign. So you get a negative 8r squared minus 7r minus 10. And then start combining like terms. So 9r minus 8, or 9r squared minus 8r squared gives you a positive 1r squared. You don't have to draw the 1. The next highest was the 6r minus 7r, which is going to end up giving us a negative 1r. And then a 16 minus 10 is going to leave us with a positive 6. So we get a final answer of r squared minus 1r plus 6. And then if you got any questions, obviously if you're in Zoom, you would be able to ask after watching this video, or you can always shoot me an email or wait until our Zoom meeting. Plenty of options there to get some help. All right. And then if you need to Google something, Google it as well. All right. So I'll talk to you guys later.